Hi students, welcome to this short session on CBSE 10 Math. The chapter name is Introduction to Trigonometry. The topic is Trigonometric Identities. So this is chapter 8 from CBSE 10 Math, exercise 8.4, page 193. I have chosen question number 2, which says write all the other trigonometric ratios of angle A in terms of secant A. I put a red rectangle on this question because this question requires the attention of the students, number one, and number two, question is also important from the point of view of the examination. So let's solve this question. Before that, let's understand properly what the question says. Write all the other trigonometric ratios of angle A in terms of secant A. You know there are totally 6 trigonometric functions, or there are 6 trigonometric ratios in all. And secant A is one of the 6 trigonometric ratios, and in this question we have to express the other 5 trigonometric ratios of angle A in terms of secant A. That means we have to express sin A in terms of secant A, we have to express cos A in terms of secant A, to express tan A in terms of secant A, cosecant A in terms of secant A, and cot A in terms of secant A. So the other 5 trigonometric ratios have to be expressed or represented in terms of secant A. Means in our final answers there should be only secant A trigonometric ratio. No other trigonometric ratio should be there in our final answers. So to help solve this question, I already pasted here the 3 basic trigonometric identities which you know are called Pythagorean identities. Sin square theta plus cos square theta equals 1. 1 plus tan square theta is equal to secant square theta, and 1 plus cot square theta is equal to cosecant square theta. And we also have here the reciprocal pairs. You know that sin and cosecant form a reciprocal pair. Similarly, cos and secant also form a reciprocal pair, and so do tan and cot. So let's solve this question now. How to write the other trigonometric ratios of angle A in terms of secant A. So I am going to go in a sequence. So the first trigonometric ratio that I am going to express in terms of secant A is sin A. Now to express sin A in terms of secant A, there is no direct relationship between sin and secant. Therefore, we have to go through another third trigonometric ratio, which is cosine A or cos A. So sin A will be expressed in terms of secant A via cos A. Now to do that, I am going to use this Pythagorean identity sin square A plus cos square A is equal to 1. So from this, I can write sin square A is equal to 1 minus cos square A. Sin square A is equal to 1 minus cos square A, and here 1 minus, in place of cos A I can write 1 upon secant square A, because we know that cos and secant are reciprocals. So this became 1 minus 1 over secant square A. I will take the least common denominator here. The least common denominator is going to be secant square A, and there in the numerator I will get secant square A minus 1. So this is my expression for sin square A, and therefore my expression for sin A, taking square root on both sides. First I'll take square root of the numerator, so that will be square root of secant square A minus 1 divided by the square root of the denominator is going to be just secant A. So here is my answer for sin A in terms of secant A. Observe that in this answer the only trigonometric ratio is secant A. There is no other trigonometric ratio. So expressing sin A in terms of secant A is over via cos A. We use this identity and we wrote sine square a as 1 minus cos square a. We replaced cos square a with 1 over secant square a, the reciprocal, and then we did a little bit of algebra and got this answer. Sin a is equal to the square root of secant squared a minus 1 divided by secant a. Now next, let's see how to express or represent the second trigonometric ratio, that is cos a. I want to express cos A in terms of secant A now. Now there is hardly any work to do here because we know that cos and secant are reciprocals. Therefore, I will just say cos A is equal to 1 over secant A. That's all. There is nothing more to do. Cos A is equal to 1 over secant A. I have expressed cos A in terms of secant A. Next, I will express the third trigonometric ratio, that is tan A in terms of secant A. Now to express tan A in terms of secant A, I have two ways to do that. One is I can use my sine and cos answers, because tan A is sin A upon cos A. I already have my answer here for sin A. This is the answer for sin A, and here is my answer for cos A. So using my answers for sin A and cos A, I can get the answer for tan A by doing sin A upon cos A. But there is an easier way than that, which is there is a direct Pythagorean identity you can see here which relates tan and secant. So here is that identity in terms of angle A. I am writing that now. 1 plus tan square A is equal to secant square A. So from this I can write tan square A is equal to secant square A minus 1. And now taking square root on both, square root of secant square A minus 1. So this is my answer for tan A in terms of secant A. This is my answer for cos A in terms of secant A. And there is my answer for sin A in terms of secant A. So the first three trigonometric functions are already represented now in terms of secant A, that's sin A, cos A and tan A. So once we cover the three primary trigonometric ratios, the other whatever remaining ratios are there to be expressed in terms of secant A, that's very easy. So here is the next trigonometric ratio, cosecant A. I want to express cosecant A now in terms of secant A. So for this I will take the help of sin A, because cosecant A happens to be the reciprocal of sin A. So cosecant A can be written as 1 upon sin A, and the sin A answer I am going to substitute from here. This was my answer for sin A, whole root of secant square A minus 1 divided by secant A. So this is going to become 1 over, in place of sin A I am going to write the whole square root of secant square A minus 1 upon secant A. And you know that this is going to get inverted finally. So my answer for cosecant A in terms of secant A is coming as secant A divided by the whole square root of secant square A minus 1. My answer for cosecant A in terms of secant A. And finally cot A. Now cot A again is the reciprocal of tan A. So you can just say cot A is equal to 1 upon tan A. I am going to use my tan A answer from here, which is root of secant square A minus 1. So this will be 1 over the whole square root of secant square A minus 1. So this is the final answer for cot A in terms of secant A. So to summarize, sin A in terms of secant A, this is the answer. And then cos A in terms of secant A, this is the answer. Tan A in terms of secant A, the answer is here. And then cosecant A in terms of secant A, the answer is here. And the answer for cot A in terms of secant A is here. So you can see in all these answers I have only one trigonometric ratio, which is secant A. So that's how we solve this problem. Write all the other trigonometric ratios of angle A in terms of secant A. So similar to this, you can expect problems like write all the other trigonometric ratios of angle A in terms of sin A, or write all the other trigonometric ratios of angle A in terms of cos A, in terms of tan A, in terms of cosecant A, in terms of cot A. So there are 5 other possible variants to this question. So here is another question that I have taken, which is question number 3 from the same exercise, and this question is relatively simpler compared to the earlier one. And this question, or these two questions, are again based on this first Pythagorean trigonometric identity: sin square theta plus cos square theta equals 1. But solving these questions also requires the knowledge of complementary trigonometric ratios. Now here I have a frame showing the complementary trigonometric ratios, or the pairs. You know that sine and cos form a complementary pair, and then cosecant and secant form a complementary pair, and tan and cot also form a complementary pair. So the first problem here says sin square 63 degrees plus sin square 27 degrees whole divided by cos square 17 degrees plus cos square 73 degrees, and the problem says evaluate. Evaluate meaning find the value of. We have to find the value of this expression. Now notice that all these are non-standard angles: 63 degrees, 27 degrees, 17 degrees, 73 degrees, 25 degrees, 65 degrees. All these are non-standard angles, and we do not know the values of the trigonometric ratios of non-standard angles. So that means this problem has to be solved by using our knowledge of complementary trigonometric functions. So first expression can be rewritten as sin square 63 degrees. I will keep it as it is. This is question number 1 I am solving here. Plus the sin square 27 degrees can be written as cos square 63 degrees. And how is that? We know that sin 27 can be written as sine of 90 minus 63. So I just written 27 as 90 minus 63, complementary, so 90. And sine of 90 minus theta is nothing but cos theta. Cos theta here becomes cos 63 degrees. So sin 27 is same as cos 63. Sin 27 degrees is same as cos 63 degrees. So here this sin square 27 can be replaced with cos square 63. And similarly in the denominator I am having cos square 17, which I will keep as it is, plus this cos square 73 degrees can be replaced with sin square 17 degrees. And how is that? We know that cos 73 degrees can be written as cos of 90 minus 17. 90 degrees minus 17 degrees is 73 degrees. And then cos of 90 minus theta function becomes sin theta, which is sin 17 degrees. So here cos square 73 I replaced with sin square 70 is equal to, now if you see the numerator and denominator both, this is like sin square theta plus cos square theta. Here we have sin square theta plus cos square theta equal to 1. So the numerator is 1, and similarly the denominator cos square theta plus sin square theta again, this is also equal to 1. So the answer is 1 by 1, or 1 upon 1, which is 1. So answer to the first question is 1. The second question can be solved similarly. Here I am doing the second part. Sin 25 degrees cos 65 degrees plus cos 25 degrees sin 65 degrees. So sin 25 I have written as it is, and now this cos 65 degrees can be written again as sin 25 degrees. And how is that? Cos 65 degrees is nothing but cos of 90 minus 25 degrees. 90 minus 25 is 65. Now cos of 90 minus 25, cos 90 minus theta function becomes sin theta, that is sin 25 degrees. So cos 65 was replaced with sin 25 degrees. Similarly here, cos 25 degrees, I'll keep it as it is, and sin 65 degrees. Sin 65 degrees can be written as sin of 90 minus 25 degrees. And sin of 90 minus theta is cos theta, which is cos 25 degrees. So here I can replace this sin 65 degrees with cos 25 degrees. So that my expression now reads sin 25 into sin 25 is sin square 25 plus cos 25 plus cos 25, cos 25 into cos 25 is cos square 25. And again from our Pythagorean identity, sin square theta plus cos square theta is equal to 1. So the answer to the second part is also 1. I hope these solutions were clear. Thank you very much for your kind attention and participation. Thank you.